In this Agnes's video, we're going to describe how to create a parameterized register specification for IP using iDesignSpec. iDesignSpec can be used in a variety of flows. You can start with Word, Excel, or any text format on the left and go to any of the outputs on the right. In this video, we're going to show you how to create a parameterized IP using Word. We're going to show you how to change the number of registers, change the number of register groups, change the default value or register offsets. Then we're going to show you how to create references to the parameterized IP and change the parameters by overriding them. We're going to show you how to create a parameterized IP block. In this block, we have num channels as a parameter. Based on the num channels, a section of the code is repeated num channel times. And then we're going to show how to create references to the IP block and change that parameter. So let's get to the code. Here is the parameterized IP block specification. Here is a parameterized IP block specification. Notice that on the top we have iDesignSpec loaded. Notice the parameters defined at the top of the spec. You can create a table with the parameters by clicking on Define. I've just added num as a parameter. I have this table already defined with all the parameters required for this IP. Notice that you can have expressions in the value as well. Notice that the channel section reg group has a repeat based on the num channels. Notice the default value here is a parameter. The offset can also be parameterized. Here the error register has a repeat, which is a parameter. So let's go ahead and generate the code. We have created a Verilog and a UVM register model. Let's open the Verilog. Num channels along with other parameters become a Verilog parameter. Notice that the expressions come through to Verilog, and these parameters are used throughout the design. So when the simulation is run, these parameters can be specified and they can be overridden at runtime. This is the UVM register model. Notice that the classes that got generated are also parameterized. Now let's instantiate this IP block in a chip. Here I have a chip X functional specification where I'm going to instantiate the IP core. I have the parameters defined for the chip, which may be, of course, different from the parameters in the IP. Notice that the value can have a complex expression. Value num is the number of registers required to hold 1 bit per channel. And since the value register is 32-bit, we need either num channels by reg width or num channels divided by reg width plus 1 register. And that can be determined by taking the modulo of num channels by reg width. Here we're repeating the value register value num times. Here we're creating the reference to the IP block as block B. When we create this reference, all the parameters in the IP block are overridden by the chip level parameters. If that's not what you want, you can set a property saying override equal to false. This property ensures that the parameters in the IP level are retained. You can also set parameters in the IP block explicitly, like I'm showing in this example, where def value is overridden by default value. So now let's create the outputs. Notice that iDesignSpec automatically brings in the latest information about the IP into the top level block, automatically calculates the register addresses and the default values and puts it in this nice table that you can see. Here is the Verilog output. Notice the parameters that were created. Notice also that the expression for value num came through appropriately with Verilog syntax. Let's see where value num is used. Based on the parameter, various constructs are created inside the Verilog. This is the UVM register model that got created. Notice that the value num expression came through. In the parameterized IP block, when you add a parameter, it's possible to make them private. When you make a parameter private, when it's instantiated in a chip level, the chip level would not override that parameter. In a way, we have created object-oriented specification documents. So we showed you how to create a parameterized IP core. We've shown how you can use the IP cores in a parameterized SoC design and control the parameters when instantiating the IP core. and overall how to take advantage of parameterization. By way of next steps, you can evaluate the full iDesign spec suite of tools. You can request a live technical demonstration. You can contact us for any follow-up questions. Thank you for watching.